Hi there, welcome to Scholastic Home Video Tutor. In this lesson, we are going to look at correlation. Today in this lesson, I am going to select a question from AQA Mathematics, Unit Statistics 1B, January 2011 examination, question number 1, which is a GCE ACE level examination. Let's go through the question. Question number 1, part A. Estimate without undertaking any calculations. Without calculations, the value of the product movement correlation coefficient PMCC, product movement correlation coefficient, between the variables x and y for each of the two scatter diagrams. There are two scatter diagrams, 1 and 2, and the variables x and y, and the points are given here. So we'll come into this one in the next page. First go through the question, and part B, it says that this table gives the circumference x centimeters and the weight in y grams of each of 12 new cricket balls. There are 12 values here. So x is the circumference length and the y is the weight in grams. So it's given here. So part 1, calculate the value of the product movement correlation coefficient. This time we have to calculate it between x and y. And part 2, assuming that the 12 balls may be considered to be a random sample, interpret your value in context. So please note that it is in context. So when you write the answer, you need to relate the circumference length as well as the weight of the ball to your statement, how they correlate after you obtain the results. Okay, let's look at the question. So we will start with question 1, part A. So here we have a scatter diagram with x and y. So the definition of correlation is that if all the points between x and y, if they lie in a straight line, we normally call it the correlation equal to 1 if it is a positive gradient line. Otherwise, if it is a negative gradient line, we call it a negative 1, but if all the points are in the same line. But in this case, the points are not in the same line but approximately linear, also positive gradient. Therefore, our answer to this one, what is the value of r? So we need to guess a value for r. So in this particular case, for the part 1, we can say r is equal to maybe around 0.6 to 0.98. If all the points are in a straight line, we can call it 1, but in this case they are not in the straight line, so there are some scattered values. So we can guess it between 0.6 and 0.98. So if you write a value in between this range, your answer is correct. So this is part 1. And part 2, in this case we have a scatter diagram here. It looks like it is slanting to negative direction, but most of the points are not related. X and y are not very related. So that means it is normally in this case, when x increases, y increases. In this case, when x increases, y should decrease, but it is not very linear. So therefore, our coefficient should not be equal to negative minus 1. If all the points are in a negative gradient line, so we can take it as minus 1. So this is a very weak correlation. So we can start with r is equal to, say, around negative 5 to about 0.02. So if there is no correlation, we can call it zero correlation. That means all the points are everywhere. So we can look it as a zero correlation. But in this particular case, there's a little bit of correlation, but it is very weak. So we can go up to negative 0.02. But definitely it's a negative correlation because the gradient is this direction, and in this case gradient was positive direction. Okay, let's go to the next part of the question, part B. So we have two values, two variables, x and y, and we need to calculate PMCC. So first thing is to enter these values into our calculator, and then we can perform the calculation using two methods. Either you use the table the given to you in your exam, or we can straight away use the values coming from the calculator. So let's see both the methods here. Let us bring up your calculator. So what we need to do is to know how to go to the statistics mode in a calculator. So here I have a sample calculator for us to try. So this is the display. I just expanded it for clearness, and this is the display that it says statistics. What we actually have to do is to select the statistics mode. Normally what I do here is I select number 6, in this case statistics mode, and we are expecting a linear correlation. So it is y is equal to a plus bx, so I need to select number 2, and then there are two values x and y. Actually it's the same thing, I just expanded here for clearness. So what I should do now is to enter the values of x and y in this calculator to calculate PMCC. So I'm going to enter them here now, so one by one. So the values are starting with x. So first I will enter all the x values. 22.5, enter. So basically you can see it here. So what I'll do is I'll close this one so it don't confuse the two things. Find, and 22.7, enter. 22.6, enter. 22.4, enter. 22.5, enter. Basically I'm looking at this row here, so 22.5, and then 22.8, 22.8, enter, and 22.6, enter. 22.7, enter, and 22.8, enter. 22.4, enter. 22.9, enter. 22.6, enter. So we have 12 values. What I did, I entered all the x values first, and then I go to enter the y values into the calculator. So always make sure that you enter the corresponding y value. If you don't enter properly, you will get a wrong answer. So in this case 22.5 x, and the y is 160.3. So I enter 160.3, enter. 159.4, enter. So I'm looking at this second row now. 157.8, enter. So 22.4 is 158. 158.0, enter. 157.3, enter. 159.8, enter. 158.3, enter. 159.6, enter. So we are here 22 points, 159.6. So 22.8 is 161.3. 161.3, enter. 156.4, enter. 162.5, enter. 161.2, enter. These are the 12 values. So you can see once you finish the y line, y column, it should be telling 22.6, the last number. So okay, so once you have these values, then what we need to do is to calculate the product movement correlation coefficient, either you can use the calculator directly or you can use the tables given. So what I'm going to do is to draw up the table that we have. So this is actually from the supplementary material given in the exam, so we can use these equations in this case. So that means our calculation is actually the product movement correlation coefficient. Actually we need to calculate this value here, R. So to calculate R, we need to know SXX, SXXYY, and XXY. So this is XXX, XYY, XXY. So what we need is this value, sigma xi squared, sigma xi, sigma yi squared, sigma yi, and sigma xiyi, sigma xi times sigma yi. So all these values actually can be obtained in our calculator. So basically what you can do is to go to the calculation menu, so options. So it is the two variable calculation, so you enter number 2 now, and then we can see all the values. Basically what we need is sigma xi squared. This is sigma xi squared here, sigma x, the suffix is not here, basically it's a sigma xi squared. That means all the x values, square them and add them. So we have the values for xi squared, it is 6. So what I will do is I will take, because we can see the values here, in there are other values like sigma y squared, sigma xy, which is required here, and then yeah, so we need sigma x also. Sigma x is here, sigma x, and sigma y here. So what I'm going to do now is to draw up all these values into the screen. So let me check here. So yeah, these are the 3 screen values that you get in the calculator when you go down. So all are together here now. So what we need are these values, sigma I squared. So what I'm going to do now is to refer to these values and try to calculate them. So we need to calculate SXX first. So I need value of sigma xi squared. So sigma xi squared is here. So that is my value here, 6142.97 minus sigma xi. Sigma xi is 271.5 full squared, divide by n. And actually n is equal to 12 in this case, because there are 12 balls, and then that is 12 here. So when you simplify this one, you get the value for SXX equal to 0.2825. So the second value is SYY. Similarly, we can substitute for sigma yi squared, that is the value here, that is sigma yi squared here, and then sigma yi. So what we substitute here, sigma yi squared 50.01 minus sigma yi. Sigma yi is here, so that is 1911.9 full square, divide by n is 12. So when you simplify this one, we get SYY equal to 36.5425. And the last value that we need is SXY. So we need this value, sigma xy. So it is equal to 43259.17 minus sigma xi, it is equal to 271.5 times sigma yi, which is equal to 1911.9 divide by, again, n is 12. So when you simplify this one, you get 2.4325. So these are the 3 values that we need to know, and then we can calculate the value of R. Therefore R is equal to SXY, which is equal to 2.4325 divided by square root of 0 point, this is xxx 2825 times xyy 365425, which is, after simplification, you can use the normal calculation mode to get 757 as the answer. That is the product movement correlation coefficient. This is RPMCC. That is by using the tables given in the supplementary material. But you can actually, instead of going through all these processes, you can use the calculator mode. Basically in the calculator, there's an option that we can go to calculate the, we'll go to options, we go to regression calculation number 3. So in that you can see the value of R. So when you do the regression calculation, you can use A and B, but for the correlation there is a value of R. R is equal to 0.757. So this is what you got here. So instead of doing these calculations, you can use the calculator function to get the value of R. So in fact the value is 757. So this is the display of the calculator. I just erase this one, so just to show the value down here. So basically it is the same value that we just now got. R is equal to 0.757. Okay, so that is part 1 of the question. So let's do the last part of the question, in which it says that assuming that the 12 balls may be considered to be a random sample, interpret your value in context. So what we got in this example is that R is equal to 0.757. So according to our theory, this is this can be a strong correlation, close to 1. Sometimes it can be fairly strong, or moderate positive, and also positive. So this is a positive. There are 3 things. One is strong, one is positive, and it's a relationship between because we need to look at context. So relationship between x and y. So in this case we need to state this thing. So when you write the statement, so because we need to give a statement here, interpret your value in context. So we can say that this is a strong positive correlation between circumference size and weight of the cricket balls. So there's a context, or circumference length or circumference size, or so basically this is between this and this. So that is the answer to the last part of the question.